Alright, so we're ready for the last section in Chapter 3, Section 3.5, which is titled using box plots to display summaries, right? So we're going to look at box plots and 5-number summaries. So the next slide looks at finding outliers, right? So remember that outliers are essentially just extreme data values. And I just want to point out that there's not just one set way to find outliers. This is just one possible way, right? So different statisticians, or maybe even statisticians with different data sets, will use a different definition for finding outliers. So it's important if you're reporting your results, to show how, like, what you use to consider outliers. If you include your outliers in your data, or you didn't, or you chose to do it both ways, right? Those are things that you'd want to specify, right? So this is just a common general way to find outliers. What we're doing is we're going to create what's called fences, right? So let me draw this, right? So here, if we have a number line, right, and we already found Q1 and Q3 in our data, right? So if here is Q1 and here is Q3, right, which means my median would be somewhere in here, right? Then what we do is we go, so we find this distance between Q1 and Q3, right, which you remember is called the IQR. And then we're going to go 1.5 of this distance to the left and to the right, right? So if this is 1.5 IQR, and over here this is 1.5 IQR, then we're going to create what's called a fence, right, or a cutoff. So we make a cutoff at where this ends and where this ends, and then any data that's not inside the fence, right, so in here is considered an outlier, right? So if your data is outside this yellow range, then your data is considered an outlier, right? And that's what this is showing, just with an equation, right? So I refer to this part as my lower fence, and I refer to this part as the upper fence. Right? So here's an example. So we're told that the first and third quartiles in our distribution of daily high temperatures in San Francisco are 59 degrees Fahrenheit and 70 degrees Fahrenheit respectively. Using these values, what temperature would be considered outliers in San Francisco, right? So the first thing that you want to do when you're trying to find outliers is we first need to know the interquartile range, right, the IQR. Remember, this is taking Q3 minus Q1, right? What's the distance between Q1 and Q3? So we would want to take 70 minus 59, we get what, 11, right, is the IQR, right? So looking at the next slide, right? So what we want to do is, so we found the IQR, right, which was 70 minus 59, which is 11, right? So then if I find 1.5 the IQR, right, so 1.5 times 11, you get 16.5. Right? So if you want to picture this visually, right? So here I have it shown, if you're okay learning through an equation, but if you want to think through this visually, I'll draw the picture over here, right? So here's my number line, right? We know Q1 and Q3. Whoops, this would be Q1. So Q1 and Q3. We found this distance in between, which was the IQR, to be 11. So then I'm going to go out 1.5 of that, right? So I'm going to go 16.5 units to the left, and there's going to be a cutoff here, right? This creates my lower fence. So then my upper fence, I'm going to go this way, 16.5 units, right? And this is my upper fence. So I want to find what these fences are, right? So so Q1 was what, 59, and Q3 was 70, right? So this value here would be equal to 59 minus 16.5, right? So we get 42.5. So this part is 42.5 degrees Fahrenheit, right? So then to find this guy here, the upper fence, we would take so the Q3, which is 70, and then add my 16.5, which gives me what, 86.5 degrees Fahrenheit. Right, so you can see how this looks visually and with the equation. So any temperature that's not in this range, right? So if the values are not in between 42.5 and 86.5, then we consider them outliers. So a box plot is another visual tool that we can use, right? So we have a histogram, which we can see some descriptives for and kind of get an idea. Another great visual to do is to create a box plot. So a box plot can help us visualize certain summary statistics. So it shows where the bulk of my data is going to lie. It's going to show where my fences are. We will identify potential outliers on a box plot. In here it says potential outliers are marked with an asterisk. So you can do an asterisk, or a lot of times, like in R and things we're gonna see, it's done with just a circle, right? An open circle. So I've seen this more frequently than asterisks, but either one is okay, right? So we're gonna show the 5-number summary, right? Which is the min, the quartile 1, the median, quartile 3, and then the max of my data, right? And we'll also show where the fences are and outliers, right? So this will also help us kind of see a distribution, right? What's going on, right? All right, so if we go down, here's an example of a box plot, right? So here's a box plot drawn. So immediately you should recognize that these are my outliers, right, in a box plot. The this line here, this shows the median, right? This line shows quartile 1. This line shows quartile 3, and where this whisker, so these lines, horizontal lines, these are called the whiskers, right? So where this whisker ends, this is the minimum or of the lower fence, right? And here, this would be the upper fence, right? So where the min and max are shown. So we're not always going to draw the whisker to the absolute min or the absolute max if they are considered outliers, right? So we're going to go to that fence, right? Essentially, right? And notice here we still have an axis, right? And this is showing daily temperatures, right? Also, you can also do a box plot going up and down, right? So we can also have a box plot going this way, right? And then we'd have a line in here. So this is showing Q1, or no, this. So if we have my axis going this way, right, and going from like 50 to up to 100, right? Then then this would be Q1, and this would be Q3, and this would be my median, right? And then you'd still have these whiskers drawn, but they would just be going up and down, right? So you can do a box and whisker like this horizontally or vertically, right? Just depends on what you prefer, right? So we were asked some questions. What's the minimum value? So the minimum value is shown here, right? So we would just put 49 degrees Fahrenheit. The median, as I was saying, is here. So we'd have 64 degrees Fahrenheit. And it says how many potential outliers are there, right? So you'd want to count how many dots. So we have 1, 2, 3, 4, 5. So that's how we get 5, right? We're counting all these dots here, right? Those are my potential outliers. All right, so this next slide is just showing you how you can hit a graph a box plot on the TI-84 calculator. So I'm going to walk you through that with an example towards the end, right? So we'll go through that in a moment. This next slot is looking at another box plot. So we can also use box plots to compare two or more distributions, right? We can have them compared side by side. So if we look at their histograms, right? So this is temperature maximums for Provo and San Francisco, right? So this is some data we looked at earlier. So we can look at their shape, right? So they both have roughly the same shape. They're both symmetric, and their center is fairly close together, right? So we had 67 degrees Fahrenheit in Provo versus 65 degrees in San Francisco. But the spread in both distributions, however, is very different, right? So with Provo, notice my data values are a lot more spread out, right? We have more variation in our data, where in San Francisco, the data values are not as spread out, right? They're closer to the center, right? So Provo, our data values are farther from the center, where in San Francisco, the data values are closer to the center. So we can create a box plot to compare both side by side, right? So I can do two box plots in the same graph to compare, right? So things that jump out to me, right? And I don't know if I pointed this out before, right? But remember, like here, this would be Q1. Whoops, let me jump down. Did not mean to do that. All right, so like here would be Q1. Doesn't like me drawing a small line, I guess, so I'll draw a bigger one. So this would be Q1, and here this would be Q3, right? So Q1 and Q3. So remember that the distance in between is the interquartile range, right? So when I draw a box and whisker plot, right, and here's my median, here's Q1, and here's Q3, then this box shows the IQR, right? So just to make that clear. Right. All right. So we're comparing San Francisco with Provo, right? So that jumps out to me is that for San Francisco, the IQR is much smaller than the Provo, right? Another thing that jumps out to me is the Provo covers a much bigger span, right, of our data values, right? The actual range is a lot bigger, right? And then also how San Francisco does have some outliers, right? These are outliers. So those are things that jump out to me when I look at those briefly. Also, I would look at their median. So their medians are pretty close together, right? So where those bars match up would be the median, right? So here and here, right? Those are pretty close together. So these are all things that we observe with the histogram also, right? So it's another way to visualize it. So these are how we can describe some of the distributions. So this shape, so they're both fairly symmetric, right? Meaning that the meaning is the center of the box, right? So if I had a box where the median was, off to the side like here, this would be an indication that it doesn't look symmetric, right? We have some skewness. So if something is symmetric, your median should be somewhere near the middle of your box, right? Also center, so 67 degrees Fahrenheit in Provo versus 64 degrees in San Francisco. So again, they're really close to the same, right? And in fact, in the box plot, they look about the same to me, right? With the spread, so you can also see that with the Provo, the data is more spread out, right? The box is wider, where in San Francisco the box is more narrow, right? So visually, that's just another way to show that. And then we can also see that both cities have 100 degrees. So if we look here, right, going down, so both cities do cover temperatures of 100 degrees. Maybe I'll do this. Right, so both have temperature in the yellow 100 degrees. But one thing that that this points out, this box plot, is that it's unusual for San Francisco, right? It's not doesn't seem like that happens very often for San Francisco to have temperatures around 100. But it's typical for Provo, right? It's not considered an outlier, right? So those some ways to read a box plot. So when we talked about the 5-number summary in an earlier section, also, right, how to find that. So with the 5-number summary, the key statistics that box plots reveal are known as the 5-number summary: the minimum, quartile 1, the median, Q3, and the maximum, right? So here's an example. It says, consider the box plot of daily high temperatures in San Francisco. So the 5-number summary would be 49, 50, 59, 64, 70, and 97, right? So even though this is an outlier, it's still the maximum value, right? Because that's what goes shown here, the max. Right? So then in the next slide, what I wanted to do is go through an example with you by hand, right, on how to draw a box and whisker plot. Oops. And I also want to show you how to do this in in R and on the graphing calculator, right? So this is the data set that we want to work with, and I want to draw a box and whisker plot with you, right? So the first thing that we're going to want to do is find our 5-number summary, right? But before we get started with that, we need to put our data in order from smallest to biggest, right? So we would do 1, and then next would be 6, and then what, 8, 9, 12, 15, and then what, 16, 18. Right? So make sure I got all of those. So 1, 6, 8, 9, 12, 15, 16, 18. Yep, I think we're good, right? So we just put our data in order from smallest to biggest, and then we want to find the median, right? So the median is going to just separate my top 50% from my bottom 50% of my data, right? So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have n equals 8, right? I have 8 data points. So since I have an even number, I need to average the two middle ones, right? So 9 and 12 would be the two middle values, right? I have 3 on this side and 3 on that side. So the median would be the average of 9 and 12. So I want to find the number right in the middle of 9 and 12, right? I want to find what's here. So I average them, I add them and divide by 2. So 9 plus 12 is what, 21, right? And then if we take 21 and divide by 2, we get what, 10.5? Right, so my median is 10.5, right? So I have 1, 6, 8, 9, 12, 15, 16, 18, and so far what I found is my median here, which is 10.5, right? So next I want to find Q1 and Q3. So Q1 is going to be the median of the lower half, right? So to the left of the green line. And Q3 is the median of the upper half, right? So to the right of the green line, or the right of the median, right? So this is Q3. So we need to find those. So Q3 is going to be the average of 6 and 8. So Q1 equals 6 plus 8 divided by 2, which is what, 7. and Q3 would be the average of 15 and 16. Right, because I want to find what's right in the middle of those, right? And again, we're finding what's in the middle because I don't have a middle value, right? So for this, I have 4 pieces of data. For here, I have 4. So remember, when we have even data, we find the average. If you have odd, you just pick whatever number exists there in the middle, right? So then here, I would take 15 plus 16. We get 31 divided by 2. So 31 divided by 2 is 15.5. Right? So then from here, what I would want to do is find my lower and upper fence. So remember, my lower fence is going to be Q1 minus 1.5 times the IQR. And the upper fence is going to be Q3 plus 1.5 times the IQR. So what we're trying to do here is identify if we have any outliers, right? So my IQR, my interquartile range here, is going to be Q3 minus Q1, which would be 15.5 minus 7. So 15.5 minus 7 is 8.5. Right? So to find the lower fence, I would take 7, subtract off 1.5 times 8.5. Right? So we do some arithmetic here. We get negative 5.75. Right? So just looking at this lower fence and my minimum value, which is 1, we don't have any outliers, right? We don't have anything to the left of negative 5.75. So at least towards the end, there are no outliers, right? Now we need to check and see if there are outliers above Q3, right? So now I would take quartile 3, which is 15.5, and add in 1.5 times 8.5. So 15.5 plus 1.5 times 8.5 is 28.25. So here my max is 18, so I don't have anything to the right of this upper fence, so I'm good, right? All of my data is within the lower fence and upper fence, so I do not have any outliers, right? So the next, I need to draw my box and whisker plot, right? And just to make this clear, right? The only thing we're missing from the 5-number summary is the min, which is here, and the max, which would be here, right? So we have the min, the max, the median, Q1, and Q3. That consists of 5-number summary, right? So now I'll draw my box and whisker plot over here. So I'm going to draw one that goes horizontally, right? So here's my axis. So let's start at 1 and go up by 2 each time, right? So 1, 3, 5, 7, 9, 11, 13, 15, 17, and we need to go up to 19, right? Because my max is 18. So I need to at least go up to 19. Right? So then now, so when I draw my box and whisker plot, I will typically start with the median. So the median is 10.5. So we draw a line. So it's a line that's going to go perpendicular to our axis, right? So that looks to be about 10.5, right, in between 9 and 11. And then we need to draw in Q1 and Q3, right? So Q1 was 7, right? So I would draw this here, right? And then Q3 was 15.5. So we need to draw a line about 15.5, right? And then so this makes up my box, right? So I just connect these, and there's my box. Now I need to draw in the whiskers, right? So my whisker is going to go from Q1, so just to label this is Q1, this is my median, and this is Q3. So now I need to draw a whisker from Q1 to my lower fence or my minimum, right? Depending on if I have any outliers. Since I don't have outliers, it's going to go all the way to my minimum, which is 1, right? So we don't draw a whisker past the fences, right? And then I'm going to draw my other whisker going from Q3 to my max, which is 18. Right, so that will stop about here, right? So here's my max, and this is my min, right? And there are no outliers, so I don't have any circles listed for those data points for outliers, right? All right, so this is how you do one by hand, right? So now what I want to do is show you how to draw one on the graphing calculator, right? All right, so let me go. So first thing you want to do is go to the stat menu, right, which is here, and then go to edit, right? Remember, this is where we're going to input data. So I already have data values in here, and you may also, if you haven't used your calculator from last time we did a video. So we have 48, 48, 53, 53.5, 54, 60, 62, and then 71, right? So you can pause this video and input that data in your calculator if you'd like, follow along. I'm just going to make a box plot with this data, right? So remember, once my data is in here, I can go to stat and I can go over to calculate and do one variable stats, right? We've done this a few times. And my data is in L1, so I can just go down here to calculate. And remember, we can see here's my mean, here's some of the x and so forth, standard deviation. If we keep going down, we can get the 5-number summary. I can get my minimum, Q1, my median, Q3, and the max, right? So this is how we can get these numerical summaries, right? So if you want to display this in a graphical, right, a box plot, then what you do is you go to second stat plot, right? So here, and then you'll hit enter for plot 1. And then, so it's already on, right, which is good. You want that on. And then we can scroll down, and this is where we pick the type, right? So remember, we chose this type here for a histogram. So if we keep scrolling through, this is the one for a box plot, right here. So if I hit enter to select that, then now I can go to graph. Right. So let me go to zoom and go to stat plot. So stat plot, zoom stat, right, is option 9. There, right? So after you hit graph, if you don't see the box plot, if you go to zoom and then option 9, which is zoom stat, your calculator will adjust and change its view. You're telling it that you want to view this in statistical mode, right? So here is my box and whisker plot for this data set, right? So here's my min, here's my max, there's my median, Q1 and Q3, and there are no like dots, right, or markings on the sides, so there are no outliers, right? There's no potential outliers labeled, right? So then the next thing I want to do is show you how to do a box plot in R. So I uploaded this Excel file onto Canvas. So I have, see, these are SAT scores. So I have a listing of 100 SAT scores, and they're marked by male and female, right? So let me show you how to do this in R, right? So remember that your Excel file has to be in a CSV format. So if we hit File, Save As, right, you'll see that I have this saved on my desktop, and the file format is CSV, right? That's how I already saved it for you, right? And notice also how my Excel file is ready to go. I have scores listed here in gender, so these are 2 variables, but going across horizontally, right, this is one person. So this was a female that got a 529 score, right? If I go down, you know, this is another person, a male that got a 621, right? So each row represents one individual, right? How I have the data set up, right? So let's go ahead and open R. So I'm going to go to edit, and I'm going to make the text larger, right? That way it makes it easier for you. So I usually do about 12 or 14 for myself, but I'll do like 16 for the video, or maybe like 18. I want to make sure you can see what I'm typing. There. All right. So remember, the first thing we always want to do is set your working directory, right? So I always do get wd, get your working directory. So what's my current working directory? And I think this just makes it easier, because now we can just copy this, right, this file path, and paste it in the set working directory. And typically by default, it's always going to be your documents. So I like to work from the desktop, right? So if you like to work from the desktop, you can do that, right? And if you don't want to change your working directory, like if you prefer working in your documents, that's fine as well, right? I just like working on the desktop because I know it's easier to save my file there. It's easy access for me to grab it, and typically I have a lot less files in my desktop than in my documents, so it just makes me feel more comfortable that I'm grabbing the right file, right? So hit enter, and again, nothing here it means it's good, right? We have no error. So now what we want to do is grab our data. So I'm going to name my data, and I'm going to tell what file that I want it to use. So I name this SAT gender, all lowercase, right? And you have to type it in exactly how you saved, right? So when you're working with R, when you're working with computer, it's very exact, right? It's case sensitive, right? Just like typing in a password, right? If you will, it has to match exactly. So I can type in data, telling it that I have a CSV file, and this is my file name, right? And that should be in quotes. Hit enter, and nothing here is good. So now I go to attach my data. So I'm telling R, hey, please use this data, right? I told you where the data is. Now I'm telling you that I want to use it to do statistical work, right? Because we can have multiple files pulled into R at the same time, and then maybe you want to work with one file for a little bit and then work with a different file. So how you change back and forth is the attaching, right? So you might be curious to why you have to do that, and that's why. So now another thing I like to do is go to names and data, and what this will do is tell me what was in the top row, what the column names were. So we have scores and gender, or score and gender, all lowercase. So it's important to pay attention to the spelling, right, and the capitalization. Another thing you can do is go to length data, and this will tell you how many. Well, this will tell me how many variables I have. But if I do length of one of the variables like score, this tells me how many individual pieces I have, right? So if you do length of the data, that tells you how many variables we have. So we have 2. And if I do length of one of the variables, that tells you how many individual cases we have, right? So I have 100 scores, right? All right, so another thing we can do, I showed you before, you can do summary and go to do your variable score, right? And what this does is this will do my 5-number summary plus the mean, right? So I have my min identified, Q1, my median, my mean, Q3, and also my max, right? So another thing you might want to do is look at the histogram, right, when you're working with data, so we can get a feel for the overall shape, right? Remember, I can right-click on that, I can print it, I can save, copy it, or save it as a file, right? So we have some options there. Oops. I don't know how that got pulled over so far. Right? So then finally, if you want to do the box plot, the command is boxplot, and then just type in your variable score, and here is my box plot, right? And how I have it listed now, it's not breaking out by gender. This is all the scores combined, right? So this would be my box plot for all the scores combined. But if we wanted to break it out by gender, we can also do that, right? So I'm going to X out, and notice here with this box plot, there is one outlier identified, right? And here's my upper fence, my lower fence, Q1, my median, Q3, right? So now if I go box plot and I go score and then this tilde button, right? So You might have to find that on your keyboard. I know if you have a Mac or a PC, it's in a little different spot. So on my PC, I hit Shift and then hit the button to the left of the number 1 on my keyboard, but yours might be in a different spot, right? So we hit boxplot score and then this what's called a tilde, and then if we type in gender, what this is telling Excel to do, or excuse me, R to do, is let's make a boxplot of the scores, but I want you to break it out by gender, right? So now if I hit enter with this, you can see it's broken out by gender. So this is where I'm able to compare side by side, right? So here's the female scores and here are the male scores, right? So some things you can compare, right? The median for the males is higher for the SAT scores, at least with this particular data set that I have, than the females, right? Also, you can notice that there are outliers with males, but there are no outliers with females, right? Also, you can notice that the females, right, between the max and the min, between the upper fence and the lower fence has a bigger range, and also the IQR is larger, right? This box looks longer than this box, so the IQR in the female is longer than in the male, right? So you can compare these side by side, right? And that's how you do that. All right, so that's all I have for this video. Make sure if you have questions, you're posting in the discussion board, send me an email. All right.